All right, now we're going to get into Chapter 8. Chapter 8, as in the last part of any of the sections in the book, goes into the practical usage, practical temperature measurement. And it doesn't really go through it in any sort of rigorous way. It just hits on a lot of topics within the realm of selecting good temperature sensing devices. And it obviously, you just got to read through it. Response time, that's an important fact, guys, depending on the application. Sometimes your temperature changes rapidly in your manufacturing process. So if you don't need to respond to a rapid change, then that's fine. You don't have to worry about response time. But if you do need to respond to a rapid change, if you have a rapidly fluctuating temperature, you'll want a method of measuring the temperature that changes as rapidly with your device. So you don't want a lot of mass to your temperature measurement device. Thermal wells are an example of a great thing to protect your sensor, especially thermocouples. But a thermal well adds mass, therefore slows down the response time. So this is just an important little fun fact. Here's a nice little picture of a thermocouple inside of a thermal well. And on the next page, on page 81, we can see a whole bunch of example thermal wells. They come in a variety of different sizes and shapes and mounting. A lot of times people can buy off-the-shelf tanks, big stainless steel tanks for manufacturing processes that have built-in mounting points for thermal wells. A lot of times these thermal wells are spring-loaded. So what happens is I get the right length thermal well to fit into that pre-welded in kind of place on that tank. And then it spring loads so that my sensor is pressed right up against the inside of that tank wall. A lot of times they have special threading. In this case, it's pipe threading. NPT means pipe thread. In some cases, they have flanges. They bolt down to the top surface of something, or side, I guess, if it's a flat side. These are usually stainless, almost always stainless, but they can come with other metals as well. And here is a list of all the different metals you can get and their recommended temperature ranges. The best ones are always the stainless ones. Process connections are the hookups to the device. A typical thermocouple assembly will have your thermocouple itself hooked to a junction point. So that is called a thermocouple head. And it often has some sort of conduit, in this case, flexible conduit, hooked to it. And that way you can have a fully sealed in connection between your process tank and your flexible conduit, which contains your wire coming away from your thermocouple. Now, here's a fun fact. These little process heads, a lot of times you can buy them so that your temperature device, whether it be a thermocouple or an RTD, then is hooked up right inside here to a transmitter. That transmitter then converts that RTD level of voltage into something that could be transmitted over a long wire, like a 0 to 10 volt signal or a 4 to 20 milliamp signal. So that little transmitter can be embedded right inside that shell, and that's actually a common device that we'll look up online when we want later on. The book also talks a little about insertion in different pipes, not just tanks, and it talks about how you would insert to reduce the amount of problems. You can have vibration in a thermal well that could cause problems with the temperature sensing. That's a common problem. You also can have the sensor itself create turbulent problem. So you have to be very careful how you mount these things. And there's a variety of problems. Thermocouple extension wires, obviously you don't want to run them too far. You're better off putting a transmitter right next to your thermocouple. Ground loops, you can read about ground loops. That means you got electrical variation, electrical difference between one grounding point and another, so that if you've got your sensor mounted on a tank and it's grounded out at the tank, and you've got your control system somewhere else in the building that's got a different ground, you actually can get some false readings because of that voltage difference. Noise, that's a common problem for all instruments. Brake protection, decalibration, shunt impedance, galvanic reaction. I'm not going to read all these to you. Take a minute to look at all the things I've highlighted and read about them. Of all of these, thermocouple aging as a technician is the one that you're going to have to be the most understanding of, because you got to replace thermocouples as they age out. You lose your accuracy. And so learning how to spot that and replace them and know that they need to be replaced is very important. All right, I'm gonna let you guys finish highlighting stuff. Now on page 87, on the right near the bottom, we get into what I consider the most important section in here, which is practical RTD measurements. Notice that right in here, they do mention in this version, as with thermocouple transmitters, RTD transmitters available that range from sophisticated smart transmitters to simple hockey puck disc-shaped forms. RTDs are never grounded. Transmitter does not have to be electrically isolated. So there's a few facts about that. Now, the good news is RTDs, resistant bridge circuits, there's a whole thing with doing that in the book. I don't think it's that important anymore. You should know that a resistance bridge is a way of measuring the resistance in one leg very accurately, but we don't need to deal with that. For modern RTDs, they all happen with the electronics that come with them. So I'm just going to slide right past that. All right, I'm going to talk about calibrators, though, on page 91. Calibrators are devices that help you calibrate a particular temperature. A black body calibrator is a device used to calibrate infrared thermometers by giving you a pure surface whose emissivity is very, very close to 1. Then you can measure that temperature very accurately with a certified RTD. Notice they're using an RTD as the calibration sensor. So you know RTDs are good stuff. And then you calibrate your infrared thermometer with an RTD black body. And we learn a little about transmitter calibration. Anytime you've got a sensor, you can use the transmitter, that little device that takes that sensor data and converts it into a voltage or a current. You can use that device as your calibration device. More often, though, we're going to find that calibration occurs in the electronics associated with the device. All right, that's all I want to go through.